Imagine a new cybersecurity analyst who spent just 6 hours on shift working a real correlated incident, not building it from scratch, but reviewing what the AI had already pulled together. In most SOCs, that analyst would be sitting in front of an empty console, trying to figure out where to start. Instead, they were reviewing correlated evidence, validating conclusions, already working at a higher level. What changed was the workflow under them. That's what I want to get into. Specifically, the first 5 AI use cases I think matter most for building an agentic SOC in 2026. The ones that change what analysts sees and what they can do in an active investigation. I've spent 5 years running live event SOCs at everything from major security conferences to sporting events. These are hard environments, short baselining windows, thousands of devices you don't control, infrastructure that's live for 5 days, and then it's gone. This year, we had the chance to deploy every agentic SOC capability we could get our hands on in one of these environments. Correlation and instant attack verification, Splunk Triage Agents, AI-powered malware analysis, automated playbooks, on-prem GPU-backed models. Some of it worked exactly as expected. Some of it surfaced questions we weren't anticipating. Here are the first 5 use cases I'd prioritize for an agentic SOC. Let's talk about the intelligence investigation layer. The first 3 use cases are about changing what analysts see before they start working. In the traditional SOC, a big chunk of Tier 1 time goes towards questions that should already be answered by the time a human looks at something. Is this alert real? What's attached to it? Have we seen it before? Is there enough to escalate? AI should be handling that first pass. The obvious starting point is using AI as an agentic Tier 1 alert triage. I think it's worth being specific about what actually makes that useful. AI agents doing the first pass triage should evaluate the alert, pull context, identify observables, look at the related activity, and this is the part people underestimate, explain what they found. It shouldn't just output a confidence score. If the result is likely true positive and nothing else, your analyst is still rebuilding all the reasoning themselves. The value is in the explanation. The agent needs to share what it found, what's missing, what the recommended next step is. Without that, you've made the process faster, but you haven't changed what the analyst actually has to do. The second piece is correlated finding, review, and routing. In a live event SOC, detections come from a lot of places: firewall, DNS, Splunk searches, partner tools, things you've written yourself. Custom security events let you bring in all those into a common workflow as standardized findings. XDR correlates them using shared observables, users, assets, timelines, and AI reviews that package and routes it. Higher confidence incidents move into Splunk Enterprise Security for deeper investigation. Lower confidence signals go into the risk index or hunting queue. Genuinely unclear cases get flagged with notes on what evidence is still missing. The routing decision becomes part of the workflow rather than a manual judgment call every time. The third is the triage agent, but what makes it work is where it starts. This one builds on the previous 2, and the sequencing matters. If the triage agent starts from a raw alert, it's spending its time reasoning on context gathering that should already exist. But if XDR has already correlated, related detections, attached threat intelligence, identified the affected asset and user, and summarized the shape of what happened, the agent starts from a much better place. The way I think about it, XDR handles the correlation and attack verification. Splunk Enterprise Security holds the investigative workspace. Triage Agents helps analysts understand and prioritize what's in front of them. Humans review and decide. Those aren't redundant steps. Each one is doing something different. These first 3 use cases change the information analysts receive. The next 2 change what analysts can do once they're in an active investigation. The next is using AI for incident summaries and worklog narratives. This sounds administrative. It's not. In a live event SOC, handoffs happen constantly. Analysts rotate, senior people get pulled in escalation, NOC partners need enough context to act. A shift change, whoever is coming on shift can't spend 20 minutes reading logs to understand where things stand. Good incident notes have always mattered. They're operational memory. What AI can do is generate a working summary that analyst reviews and corrects rather than writes from scratch. What happened? What evidence is there? What's been done? What's still open? It's not replacing judgment. It's giving analysts something to react to. It also creates an audit trail. If an AI agent reviews an incident and then drew a conclusion, You need a record of what it saw, what it concluded, and what the human decided to do with that. That's what makes agentic workflows accountable over time. That brings us to our next use case, natural language SPL and guided investigation. A lot of analysts, especially early in their careers, know what question they want to ask before they know how to phrase it in SPL. Show me all the DNS activity for this host over the last hour. Find other devices that contacted this domain. Summarize what this user was doing before and after the alert. AI-assisted search translates those into working queries and investigate paths. The thing I'd flag, this raises the bar on data quality. It doesn't lower it. If your fields are inconsistent or your source typing is off, the agent reasons over bad evidence. Get your data in good shape before you lean on this. These 5 use cases, triage, correlation, enriched investigation, incident summaries, and natural language search, are all the foundation of an agentic SOC, and all of it is buildable now, not theoretical. What I focus on before layering in more is clean data, consistent field naming, and source typing that holds up under load. Get those right, and the next 5 use cases, your evidence analysis, response automation, detection engineering, and such, land on something that actually works. If you have any questions about any of these, or you're running into something specific in your own environment, drop it in the comments. Stay tuned for part 2, where we'll cover what happens when you found something and need to act, malware analysis, response decisions, proactive threat hunting, and how an agentic SOC compounds improvement over time.